Well, hello guys and welcome back to Mr. G Physics. This time we're going to be solving question 6 from the work, energy and power consolidation material. This question says the diagram below illustrates a box of mass 50 kg which start from rest. We can start writing some information here. The initial speed is equal to 0 meters per second at point A and slide down a rough incline of length 10 meters. The 10 meters is the displacement, which makes an angle of 25 degrees with the horizontal. This one is a degree here. With the horizontal, that is a degree there. It undergoes a constant acceleration of magnitude 3 meters per second square while sliding down the incline. And you have this one. The only thing I'm going to accelerate to write is the acceleration is equal to 3 meters per second square down. I'm not going to write the word. I'm going to rather do a line. The acceleration is in that direction. And then question 6.1, how does the total mechanical energy of the box at point A compare to the total mechanical energy of the box at point B? Write down only greater than, less than or equal to. And the answer is greater than. So the greater than is the correct answer, and you get 1 mark for that. Now, why is that so? Because there is friction throughout the sled, so energy is being converted into another type. So that is the situation here. Mechanical energy is not conserved because there is friction. They don't ask you to explain. Question 6.2, state the work energy theorem in words. This one is a very easy definition to say the net work done on an object is equal to the change in kinetic energy. There is 2 mark, and guys, this theorem is given to you. Net work is equal to change in kinetic energy. There we go. That is in symbol, but they want it in word. The question 6.3, the box reaches point B at the bottom of the slope. Calculate the following. And then they want to calculate the velocity of the box at point B using equation of motion. Now, no, they say using equation of motion. You cannot use the energy approach here. They want you to use equation of motion. And that is why you have the acceleration. We can answer that question 6.3.1 in this side here is enough space, 5.3.1. Okay, so now we do have, what data we have? We have the initial speed here is 0 of velocity. The final velocity here, we are looking for it. We have the displacement, which is 10 meters, is given to us here. We have the acceleration, which is 3 meters per second square. So we have everything. What formula will be more suitable for us to use? Final speed square or velocity is equal to initial velocity square plus 2 times the acceleration multiplied by the displacement, or no, y, I'm thinking of projectile, multiplied by the displacement, and the rest is substituting because we have everything here. Then the final speed is equal to 7.75 meters per second. That is the final answer. The direction they said here, calculate the velocity, have a direction, so you're supposed to say down the slope. Okay, there we go, and that is the answer. So if you do this one, in this case for this question, the marks they gave was 1 for the formula, 1 for the fast substitution, 1 for the magnitude of the velocity, 1 for the direction. Remember, the marks are not always the same, but you can give mark for your work here. Okay, question 6.3.2, calculate the work done on the box by the gravitational force. So calculating the work done on the box by the gravitational force as it moves down. So we're going to solve that one in a new page. A new page somewhere, maybe even here is enough space for that one, or a new page. Now remember, I like to do always the free body diagram. It's one of the important parts. The x will correspond with the displacement, and the gravitational force is pointing down here. This is the gravitational force. Now, the angle between the gravitational force and the displacement is this angle here. This one is the theta we are looking for, we need. Okay, now this theta, if the object is moving down, theta is going to be equal to 90 minus the angle of inclination minus the angle of this slope. In this case it was 25 degrees, so we can say that theta here is equal to 90 minus 25 degree, which is equal to 65. This is the angle between the gravitational force and the displacement. So if we come here, work done by the gravitational force is equal to the product of gravitational force, displacement, cosine of theta, which in this case is 65 degrees. You move on, the work done by gravitational force is equal to mass acceleration due to gravity, displacement, cosine of 65. Now we have all the numerical values we can substitute here. So when you calculate this one, you get that is equal to 2070.83 joules. This is the work done by the gravitational force. And this time they give mark for the formula for the substitution of the numerical values here, and one for the angle and one for the final answer. Remember, not always you get the distribution of the marks in the same way. Okay, now we move on. The next question say calculate the work done on the box by the frictional force. Now I want you to look at the formula. Question 6.3.3. Work done by friction is equal to the product of friction, displacement, cosine of theta. The angle between friction and displacement is 180 degrees. Note the friction is pointing in the opposite direction of motion, and the angle with the displacement will be this one here. Okay, this one is 180 degrees. But what is the problem, guys? What is the problem if we do this one? We don't have friction, so we're going to have two unknown in this specific question. Okay, so what we are going to do is we are going to use the work energy theorem rather than this one. So for this question, we're going to start with the work energy theorem. Work done by the net force is equal to change in kinetic energy. If we go now here, what are the forces acting? The object is sliding down. So there is the gravitational force, which we already calculate. There is the friction, and there is also normal force. There is also normal force acting on the crate. So those are the forces acting. If we want, we can substitute all those. So this one is going to be equal to the work done by the, for instance, normal force plus the work done by the frictional force plus the work done by the gravitational force. This is equal to half mass final speed square minus half mass initial speed square. Now we can calculate all of them separated. It's entirely up to you, but we already have one of them. We have the gravitational force, and you should know that work of the normal force, let's do it real fast here. Work done by normal is equal to normal multiplied by the displacement multiplied by the cosine of 90 degrees, and therefore this one is equal to 0 joule. Note the work done by normal not necessarily always is going to be 0, so be careful with that one there. And therefore we can substitute everything we have. Work done by friction plus the work done by gravitational force is already calculated and is equal to 2070.83 minus 2000 is a plus 2070.83 is equal to half. The mass of the crate is 50 kilograms. The final speed we also did calculate it previously here at the top, 7.75 multiplied by 7.75 square. Let's move all this one a little bit to the left. I want to have enough space here, so let's move it a little bit to the left there. And this one minus half multiplied by 50 multiplied by 0 to the power 2, because the initial speed of the object is 0. Therefore, this one is 0. So we get here that the work done by friction, if you do the calculations, you get that is 1,501.56 minus 2,070.83, and therefore the work done by friction is equal to negative 569.27 joules. That is the work done by frictional force. That is the final answer for this question. If we give marks here, you have 1 mark for starting with work energy theorem, you have 1 mark for this substitution here, you have 1 mark for this substitution here, and you have 1 final mark for the final answer. That is 4 marks, guys. Quite simple. And then the next question is question 6.3.4. Calculate the magnitude of the frictional force. Now we are going to use this formula because we do have already the work done by friction. So if we're starting from the work done by frictional force is equal to frictional force multiplied by the displacement multiplied by the cosine of 180 degree, and we have all the values. So we can substitute. This one is negative 569.27. This is equal to friction, which is what we are looking for. The displacement is 10, and then this is cosine of 180 degree. Guys, this is simple math. You will get that frictional force is equal to 56.93 Newton. This is the magnitude of the frictional force. If you do that, you get the last 3 marks of this question, 1 for the formula, 1 for the substitution, and 1 for the answer. The question says calculate the magnitude of the frictional force, and this is the magnitude of the frictional force. Guys, thank you for watching. I hope it helped. If it helped, thumb up, subscribe for the channel, share the question, write comments, and I'll see you next time. Mr. G here.